We all know that the world is changing along with its entities, and soil or land is one of those changes that is happening around the world due to human activities and natural phenomena. Land use is the term used to describe the human use of land. It represents the economic and cultural activities. Example, agricultural, residential, industrial, mining, and recreational uses that are practiced at a given place. Public and private lands frequently represent very different uses. For example, urban development seldom occurs on publicly owned lands, example parks, wilderness areas, while privately owned lands are infrequently protected for wilderness uses. Effects of land use changes. Land use changes occur constantly and at many scales, and can have specific and cumulative effects on air and water quality, watershed function, generation of waste, extent and quality of wildlife habitat, climate, and human health. Land development. Land development creates impervious surfaces through construction of roads, parking lots, and other structures. Impervious surfaces contribute to non-point source water pollution by limiting the capacity of soils to filter runoff. Affect peak flow and water volume, which heighten erosion potential and affect habitat and water quality. Agricultural uses. Agricultural land uses can affect the quality of water and watersheds, including the types of crops planted, tillage practices, and various irrigation practices can limit the amount of water available for other uses. Livestock grazing in riparian zones can change landscape conditions by reducing stream bank vegetation and increasing water temperatures, sedimentation, and nutrient levels. Agricultural land use may also result in loss of native habitats or increased wind erosion and dust, exposing humans to particulate matter and various chemicals. Land pollution. Land pollution is a heavy topic with its direct impact on the environment and consequently on the health of humans, animals, and plants. Soil pollution is a real problem that involves both political powers and citizens. Soil is not a renewable resource. Its degradation can be rapid, a few years or decades, while it takes several thousands of years to form and regenerate. What causes land pollution? What are its effects? And what are the possible solutions to prevent it? Well, let us discuss deeper about land pollution. What is land pollution? Land pollution refers to all forms of pollution affecting any type of soil, agricultural, forestry, urban, etc. Soil pollution is a disruptive element for many biological resources and ecosystems. A soil is polluted when it contains an abnormal concentration of chemical compounds potentially dangerous to human health, plants, or animals. There are different types of land pollution: agricultural land pollution, chemicals, solid waste. Land pollution causes. Human activities are the main causes of land pollution. Urbanization. Urbanization is another source of land degradation. The artificialization of soils can cause rapid and consequent carbon depletion, which contributes to climate change. Besides, it fragments natural habitats, ecosystems, and landscapes, affecting biodiversity. Is land degradation only resulting from human activities? Well, natural disasters such as drought, floods, and volcanic eruptions, or technological events like radioactive fallout following a nuclear test also produce soil degradation. Land pollution effects. Soil pollution can harm public health and animals, as well as the quality of the groundwater and surface water. Its effects are of several kinds, namely deferred or immediate, but also direct or indirect. On the environment, contamination of groundwater, loss of topsoil, water nutrient enrichment, and increased risk of wildfires because of the dry conditions created by the pollutants in the soil are among the consequences of land pollution. On wildlife, as land pollution and soil erosion progress, animals are forced to shift habitats and adapt new conditions. As a result, some species are at risk of extinction. Land pollution prevention. How to solve land pollution? Here's a list of soil pollution solutions. First, cleanup. Environmental remediation consists of removing pollution from the soil, groundwater, or surface water. Bioremediation or microbes and phytoremediation or plants can be used to convert the pollutants into harmless products. These are natural solutions that need to be supported by in-depth actions. Second, green agriculture. Sustainable agriculture is essential as it is meant to control the impact on the cultivated environment by minimizing the external contribution, which is phytosanitary products, by diversifying the cultures, and by using biological treatments. Third, sustainable forest management. Conservation of the forests is key. Without the protection of the trees, the land becomes dry and starts to erode. Therefore, sustainable forestry or logging is crucial to saving the soil from pollution. Fourth, proper waste disposal. Be it for industrial or household waste, efficient waste disposal is one of the most effective ways of curbing land pollution. This especially applies to toxic and hazardous waste disposal. Fifth, the 3 R's rule and education. Reducing the use of non-biodegradable products will lower plastic pollution and eventually have an impact on land pollution. This is why it is very important to reuse and recycle every possible item. Education should also play a major role in efforts to protect the environment from land pollution. Protecting our land and preventing the pollution of land should be done worldwide in partnership of public and private sectors because having a better and stable soil quality made us comfortable of living without those factors that may deplete the formation of landscape. The urban areas influence the pollution of land because of its artificial soil extension which diverted from mountains and that it depletes the landscape of mountain. Also, from irresponsible industries that produce or spill chemicals on lands which makes land contaminated. Moreover, natural disasters could make the soil or land become polluted. Our immediate action to our motherland must be intensified towards renovation and regeneration of our land where we are standing at the moment. Natural resources. Natural resources are usually either renewable or non-renewable. The former refer to those resources that can renew themselves in time. These include living resources like forests or non-living ones like wind, water, solar energy. Non-renewable resources, as the name implies, are those that can no longer be tapped once the available stock at the site is exhausted. Once we use them, there isn't any more. Mineral resources are non-renewable. Fossil fuels, which are formed from the fossilized remains of prehistoric organisms, are also considered non-renewable even though they can renew themselves given a few million years. Fossil fuels currently account for about 90% of the world's energy consumption. They provide around 66% of the world's electrical power and 95% of the world's total energy demands, such as for heating, transport, electricity generation, and so on. Our consumption of fossil fuels has nearly doubled about every 20 years, which is quite an alarming statistic given that their levels are running dangerously low. Natural renewable resources such as wind and water have been used throughout history until recently were a predominant energy source. In many developing countries, biomass remains the primary energy source for much of the population. Renewable resources have the advantage of producing lower emissions of carbon dioxide and reducing reliance on fossil fuels. Natural resources are also substances that occur naturally. They can be sorted into two categories, biotic and abiotic. Biotic resources are gathered from the biosphere or may be grown. Abiotic resources are non-living, like minerals and metals. Energy. We use energy every day of our lives. Our electronic devices require electricity for power. Our streetlights need the same for lighting. Our vehicles require gasoline and diesel. We fuel our homes with domestic oil, propane, or electricity from a national or local grid for lighting, heating, and for powering our devices. You're reading this article on a website that is hosted on a server that needs power, as does the computer with which you are viewing the site. The places we work use computers, phone networks, security systems, and servers, as do our shopping malls, parking lots, sports stadiums, cars, airplanes, and so on. All of these things require power from fuel. Renewable energy resources. Renewable energy systems use resources that are constantly replaced and are usually less polluting. Examples include hydropower, solar, wind, and geothermal. We also get renewable energy from burning trees and even garbage as fuel and processing other plants into biofuels. Wind energy. The moving air or wind has huge amounts of kinetic energy, and it can be transferred into electrical energy using wind turbines. The wind moves the blades, which spins a shaft, which is further connected to a generator which generates electricity. An average wind speed of 14 miles per hour is needed to convert wind energy into electricity. Wind-generated electricity met nearly 4% of global electricity demand in 2015, with nearly 63 gigawatts of new wind power capacity installed. Solar energy. Solar energy is the light and heat procured from the sun. It is harnessed using an ever-evolving technologies. In 2014, global solar generation was 186 terawatt-hours, slightly less than 1% of the world's total grid electricity. Italy has the largest proportion of solar electricity in the world. In the opinion of International Energy Agency, the development of affordable, inexhaustible, and clean solar energy technologies will have longer-term benefits. Biomass energy. When a log is burned, we are using biomass energy. As plants and trees depend on sunlight to grow, biomass energy is a form of stored solar energy. Although wood is the largest source of biomass energy, agricultural waste, sugarcane wastes, and other farm byproducts are also used to produce energy. Hydropower. Energy produced from water is called hydropower. Hydroelectric power stations, both big and small, are set up to produce electricity in many parts of the world. Hydropower is produced in 150 countries, with the Asia-Pacific region generating 32% of global hydropower in 2010. In 2015, hydropower generated 16.6% of the world's total electricity and 70% of all renewable electricity. Tidal and wave power. The Earth's surface is 70% water, By warming the water, the sun creates ocean currents and the wind that produces waves. It is estimated that solar energy absorbed by the tropical oceans in a week could equal the entire oil reserves of the world, 1 trillion barrels of oil. Geothermal energy. It is the energy stored within the earth. Geo for earth and thermal for heat. Geothermal energy starts with hot molten rock called magma, deep inside the earth which surfaces at some parts of the earth's crust. The heat rising from the magma warms the underground pools of water known as geothermal reservoir. If there is an opening, hot underground water comes to the surface and forms hot springs, or it may boil to form geysers. With modern technology, wells are drilled deep down the surface of the earth to tap into geothermal reservoir. This is called direct use of geothermal energy, and it provides a steady stream of hot water that is pumped to the earth's surface.
Yeah.